All right, so today we are moving on to industrial Ethernet. There is part of this in chapter 4 in your little book. There's also part of this in chapter 11 of the Industrial Data Communications Best Practice Techniques ebook that you guys have access to. So if you need more information, you can go to those two sources or, ask me your questions whenever they come up. So the first thing that I want to talk about today is 10 base what, or base what, huh? As you can see on the screen, we have lots of different bases on here. We've got 10 bases, we've got 100 bases, we've got 1,000 bases.
Can't see your screen.
Son of a biscuit. There we go. All right, so we've got lots of bases going on here. So a lot of different things going on here. Now, this, I believe, is all part of IEEE 802.3. All right, IEEE is the industrial... I always have a hard time remembering this. There we go. The Institute of Electrical and Electronics Engineers. All right, basically, it's the standardization people. It's the ones who come up with the standards for things. So this is IEEE 802.3 standard. It's also known as the ISO, which is the International Standards Office, something along those lines. And it's 8802.3. I don't think I might have put an extra 8 on that by accident, but anyway. So this is really overall defining a range of media types that can be used for networks. All right. And the 10, the 100, and the 1,000, that is really dealing with how fast we can communicate over this. So the 10 would be 10 megabit, the 100 would be 100, the 1,000 would be gigabit. All right. So these are those different standards. And obviously there are other standards because we are moving past the gigabit network standard. We are, you can get 2.5 gig, 5 gig, 10 gig all over Ethernet at this point in time. But again, overall, 1 gigabit. Oh, that is plenty for almost anything that you'll have to do in the industrial network. All right, you're not sending lots and lots and lots and lots of data, or you're not sending large amounts of data. You might be sending lots of packets and things because you're constantly transmitting information, but we're not sending lots and lots and lots and lots of it in very high quantities. So that is one thing to just kind of keep in the back of your mind. And let me go ahead and change that. There we go. All right, so 10 base 2. All right, so again, this is 10 megabit. This is what they're calling thin coaxial wire cable. All right, so we have 2 is thin, 5 is thick. All right, and if you want to know the differences, the thin is 1/4 inch in diameter. The thick is 1/2 inch in diameter. So 0.25 versus 5. All right, or 0.5. So yeah, thin versus thick. Based on that, I'd say most of our home cable, home coax that you probably have in your house is going to be of the thin variety. All right, so just kind of something to think about. Doesn't necessarily mean that that's the max it can do, but that's kind of what that standard is telling us. The T is a twisted pair, all right, and this is going to be unscreened twisted pair. The conductors are 0.4 to 0.6 millimeters in diameter. This is going to be based on a hub typology. And then the 10 base F, that is actually optical fiber. This is still, again, only 10 megabit, but this is going to be based on a point-to-point topology. So there are just some very specific standards that have just gone along with all these things. For the most part, I'd say this 10 base kind of faded out. A lot of equipment can still handle only 10 megabit per second, so most switches are backwards compatible. So, you can run a 100 megabit switch with only 10 megabit connections. And maybe we'll show you guys that, which I find it really interesting. In the classroom, we have PLCs, 6 of them. They're exactly the same PLC from what I can tell, with the exact same everything. But yet one of them connects to the network at 10 meg and the rest connect at 100 meg. I don't know why. Doesn't cause any issues for us, but it's just kind of really interesting to me. So if we move then, oh, here we got Jacob now on his iPhone. Now if we move into the 100 base option, all right, that takes us into 100 megabit, obviously. So 100 base T, no X, nothing after that, just 100 base T is kind of the identifier for all 100 megabit systems. All right, so 100 base T. So the TX, that one's actually going to be copper. The FX is going to be fiber. The T4 and the T2 aren't really actually ever used. T2 especially, it was supposed to operate over just 2 pairs of Cat3 cable, but no vendor ever actually implemented it, which amuses me. You would think that they'd be like, oh, this standard exists, if that's an interesting standard, we should use it. But no, no one ever actually used it. No vendor ever implemented it, which I find really interesting. Uh, T4 was designed to operate 100 megabit over 4 pairs of Cat3, but this never actually gained widespread acceptance. So again, just kind of one of those things that if you ever hear about it, it does exist, but it's basically never used. So this TX, this is really the standard. And until recently, I'd say that's kind of what all computers of these days were coming with, was this 100 base TX option. Ethernet, 100 megabit. Again, plenty of speed. Most people don't even have 100 megabit coming from their ISP, so the only benefit you have of this 100 megabit connection is on your local network, and that's only good if you're trying to stream or access lots of information from those local devices. So not normally you're ever going to see that much data being used. All right. And our last category is the 100 base or 1000 base or gigabit Ethernet. All right, SX is a short wavelength fiber, LX is long wavelength fiber, and CX is a short copper cable version based on the fiber channel standard. All right, so 10, 100, 1000, and probably actually the most important here part is really just the 10 base, 100 base, or the 1000 base. That's really what you're going to see the most of. And even that, if you're looking at Ethernet connectors or components on computers, most of the time you'll see 10/100/1000, or maybe even higher than that. Just so that references that it can handle all of those different options. So just kind of something to keep in the back pocket for you when you are trying to be networking and dealing with these types of things. Now we're going to go back a little bit of history here. We're going to dive into the world of early Ethernet. All right. And this was primarily developed for office type environments. All right. This is even before the houses had Ethernet in them. All right. This was designed for office type environments, servers where communication was absolutely necessary. All right. And if you think about it, it's like we're after running cables and things like that. There is a cost with networking. It's not free. All right. It might be pretty cheap in the long run, but it's not a free technology or a free upgrade. It's okay, we do have to get a connector going from point A to point B. And if you have old buildings and things like that already, how do you get those wires run? And, it does take time to run wires, especially to run them properly. So just something to kind of keep in the back of your pocket here. All right. There have been lots of rapid advances over the years. As I said, already we're at 2.5 gig internet. Ethernet is actually coming to home computers at this point. And again, I don't understand why. Most people have absolutely no need for it. Now, it's not on everybody's computer yet, and I don't actually truly see it becoming on everyone's computer for a few more years. But it is available on some higher end motherboards that gamers and things like that might already be buying just to have because they need some other stuff from that motherboard. So it does exist. All right. Now, what I'm showing you over here on the right is an N-type connector. All right. This is a coaxial based connector. This one is an adapter from one type of connector to N-type, but it is an N-type connector. And this was fairly rugged. All right. If you look at it, it is a metal connector. Probably would be crimped onto the cabling. You'd have the shielding would be continuing through to the connector, so we got nice protection there. But metal connector and its screws. The screw base, that is one of the big keys to having a nice rugged connector, not something that's just going to pop out and be all flimsy and things like that. So it is a good connector in the long run for industrial environments, right? It will probably stand the test of time if you use these types of things. Some of them you could have rubber gaskets and things like that in them to help create a sealing to make a water type connection. So these screw type connectors are actually a big thing. If you ever look at industrial equipment, you will see a lot of connectors that have threading on them or good retention. All right. So just kind of something to think about. Remember the cabling that we used for early coax was called RG8, not early coax, even current coax is RG-8. And this is a really good impervious to electrostatic interference. I didn't hook up my fancy drawing system today. But if you remember, we have a copper coil or copper wire down the center with a another copper sleeve with some space between it. So we have, a plastic insulating layer in here that protects, that keeps these two from actually hitting each other. All right, and also any interference that this wire could possibly radiate actually gets dispersed completely in theory in that center insulation. And then around the outside of this, we also have more insulation. So there's a lot of insulation going on a coax cable, which is a great for interference and things like that. It's shielded, so it's protected. Now, in theory, we do only have one data wire, so we are only at half duplex here, so we only can send or receive at the same time. In theory, if we're doing digital, if we're doing analog, maybe we can do both at the same time. So, but definitely not a bad starting place when it really comes to thinking of all of this. We've got nice, good quality connectors and good quality cabling and those types of things. However, as we move on to more standard Ethernet today, at least, all right, we are in that 10 base T or 100 base X category. We are using, for the most part, at your home, Cat5 UTP cable link. All right, with an RJ45 connection. Now, 10 base, 100 base, again, the biggest issue we have in industrial networks is not our transfer speeds. All right, it's how long physically does it take for me to send a packet from one location and for that to get delivered to another. It's not, oh, well, we have a throughput of 100 megabits per second. That doesn't matter. We're probably only sending like 2 or 3 bits per second, probably 2 or 3 bytes or whatever per transmission. Like we're not sending a lot of information. But we need it extremely fast. A lot of these things are very time sensitive. So speeds aren't really our big issue. It's more of a time issue. Oh, green, bad color, Greg. Timing is more of the issue that we really care about when it comes to our network connections. So RJ45 for home use, and I'm even going to really specify home use here. RJ45 is a fine connection. All right, it gives us 8 wires connected very reliably in the long run. All right. However, when it comes to ruggability of this connector, it kind of sucks. All right, I'm sure many of you have had this stupid retention clip right there break off on you. All right. Now, if that breaks off, can you still use the connection? Yeah, you can still use it. There's no big issue about that. Nothing fancy going on in the long run. You could still slide it in. There's just nothing physically holding that connector into the plug anymore. Right? So I don't know about you. I've had that happen so many damn times on cables, and most of those cables I'm actually still using. It's just in a location where I'm not worried about things getting unplugged. Maybe up in with my router or on something that's not super dire important for our network connection, but I still have those cables lying around because I'm like, well, the rest of the cable's good. All right. Now, if I was smart, I would just re-terminate it, which would, basically just cut the end off, strip some wire back, and make a new connector. And again, not the end of the world, very easy to do. And in fact, you guys are going to be making connectors next week. So we will be going through that process of actually how to do it. So overall, that is kind of a crappy connection. All right. And then the other issue that we have is the Cat5 cable itself. All right. It is somewhat electromagnetically interference resistance. All right. And that's because of the twists. All right. Because inside this cable, remember those wires are doing something like that. That's, the one color, and then the other color is white and orange. They're doing this type of twisty action, which means anything that gets induced on one wire gets induced on the other, and normally we're doing opposite signals, so we're sending positive on one and negative on the other. I should write down here so you can see it better, or something along those lines. So that twisting helps. Basically, anything that does get induced gets induced on both lines of the communication, which allows us to basically ignore that little bit or whatever that problem and maybe just resend a packet or two. So it does have some resistance to this electromagnetically induced interference. However, it is not truly resistant. All right, there's a lot, and I mean a lot, that could be better about this. However, it is in its name, right? UTP, unshielded twisted pair. So that twisted pair helps, but it's not a perfect solution. And again, in our homes, in our office settings where things aren't like super critical, if we lose a packet and it takes another second for us to get that packet again, no big deal. However, in industrial applications, that second could be the difference of someone's finger getting cut off. So that is definitely something that we want to be aware of, to say the least. So got to keep that in mind. So, but this is kind of where modern industrial now. You're going to see some of these cables out there. Is really what it comes down to. However, we are moving away from this in the industrial Ethernet category, and we're moving towards a few different things. One, screened or shielded twisted pair, such as Cat5i. Cat5i is foil and/or braids for full RF EMI protection. All right, that I believe is the industrial. So this is actually saying foil and braids, not or. But we'll come back to that in a minute. And then the coating. All right, if we go back to this, the blue on this screen. All right, it is some sort of rubbery plastic. All right, there's nothing super fancy about it. And again, in your house, you're not having a lot of wear resistance. Normally, you run an Ethernet cable and that thing just sits there in the wall or wherever for however long, and you're good to go. Industrial environments, again, we got lots of moving parts. We've got dust, we've got heat, we've got all sorts of things. So that cable may be flexing a lot, or whatever the case, or maybe getting stepped on or hit by accident, or so that cable could slowly be getting worn over time. So another thing you just need to keep in the back of your mind. But anyway, so the outside of these industrial Ethernet cables are going to be a different material. Traditionally, they're going to be a flexible polyurethane. So that way it has the longest performance life in harsh industrial environments. All right. And you may think, why don't we just do all Ethernet cables that way? And overall, I would agree with you. That would make sense. Let's just rock everything, and everything would be better. There is actually a tough Ethernet cable. Helps if I can spell. Is it? No, this isn't it. There's one that has that's cut resistant and this resistant, and it's like, what the hell? It was online as tech tips like a week or two ago about, and they were towing cars with it, and they plugged it in and everything still worked, and beating the crap out of it, and it still worked, and they were able to cut through it with a pair of scissors, but it was supposedly cut resistance. So, but anyway, so the cabling, the jacket itself is also going to be a bit more rugged per se. And this does go towards fiber optic cables as well, though outside of those would have to be protected a bit more. Now, fiber optics do have the benefit of not having that interference issue. So if interference is your big worry and not ruggedity, maybe fiber optics is the way to go, right? We talked about that a week or two ago at this point, about how, uses glass, uses light, basically no interference from outside will really screw with it. Biggest issue there is going to be wear and or breaking the cable or fracturing the cable from lots of movement like that. So again, there's always going to be downsides to everything. Now, when it comes to the connector, all right, I was reading about this. I was hearing D-type connector, and I'm like, what is a D-type connector? I've always heard this called a sub-D. All right, so they're talking about that type of connector right there. That was a horrible arrow. Let's try that again. There we go. All right. So it'd be a mini D, or a DB9 might be another way you've heard of it. So this would be like that same exact connector that we have on serial connect cables. Same thing that you'd have on your laptop, or older laptops, older desktops, those types of things. So either way, it's a good connector. It has screw terminals. Normally you would see a little threaded insert right here on both sides. So the one connector has little screws built into it, just like your VGA or DVI cable would have. So there is a physical connection being screwed into that thing. So again, much more resilient than those little crappy plastic Ethernet connections. All right. I guess the one thing I also did want to point out is, if I come back here, maximize this, there are such things as rugged RJ45 connections. All right, and I've got a whole bunch of them showing up here on the screen. Actually, let's press that button. Yeah, we'll just zoom in on that corner. All right, so you can see these have, nice big metal threads around them. There's a lot going on here. So there are ways to have a more rugged RJ45 connection. Now, all of these, or like basically all of them that I see, do still have that little place for that little plastic clip to go in. All right. So that's actually, if you want to plug a normal cable in, you could still plug a normal cable into this, which does actually, in theory, make it a nice universal thing. So it's not a super specialty cable or you have to get adapters or things like that. So there are definitely benefits to go kind of sticking with a more standard connection type. All right. Um, but yeah, and then these would be much more secure and those types of things. So there is always going to be a bit of a give and take going on. And luckily, it comes down to what equipment you buy and what is available for said equipment. So yeah, that's really the end game here. It's like, well, we're going to use Siemens-based PLCs, and they're going to use the D-type connector for their Ethernet, or they're going to use this M12 factor. All right, so M12 is what you're seeing right there on the end. All right. Um, that's just showing it next to an Ethernet cable for you by size. These DB9 connectors, they're yeah, maybe the Ethernet cable or plug would be from that point to like that point or something. They're a little bit bigger, those DB9 connectors. And again, you can keep your shielding because this is metal, and you'd have metal on the other one, so you can still have RF protection going on those DB9s. Obviously, down here on these M12s, you have metal connection. You're going to screw onto it, so you have good shielding there. For M12 connectors with industrial applications for Ethernet, we are going to use the 8-pole variety. So the poles would be the number of pins going on in here. So this one would have 8 of them. And there are ones that have more or less. All right, if you ever look at some military connectors, they're like big honking circles, and there's like 20 or 30 different pins in there that allows you to connect things very securely with screw-in threads and those types of things. So just again, something to kind of keep in the back of your mind. The M12 form factor is governed by IEC 61076. All right. And this is widely accepted in the field bus and automation applications, which is one of the reasons why people are liking it for the Ethernet in the industrial environment. They're already being used. They already know these connectors work. There's, why screw with something if it ain't broke type of thing. And obviously the reason is, well, there's a better option out there. Why are we moving away from serial? Well, Ethernet's more, it's a better option, longer distances, maybe faster transmission speeds, lots of things going there. So that's why we're moving to it. Well, there's all the downsides. So we're kind of trying to merge two things like this. These types of connectors do offer excellent protection against moisture, dust, corrosion, electromagnetic interference, radio frequency interference, mechanical vibration, shock, UV radiation, and extreme temperatures. So, a lot going for this connector in the long run other than price. That is why the standard Ethernet connection is its standard Ethernet, RJ45. That thing is like a penny, every one of those connectors. Stupid cheap for at least the standard ones. I want to go back a few slides for a second. Let's quick go back to this one. All right. Most Ethernet cables, when you are making them, let's go ahead and erase all the ink here, are not going to have wires sticking out the end like that. All right. This is a special type of Ethernet connector, which is a bit more expensive, which drives me absolutely bonkers because I'm like, well, the only difference is there's a freaking hole at the end. Like, why is it so much more expensive to make this type of Ethernet connection than the normal ones that don't have the holes in the end for the wires to go through? But this one is a special type, so you can actually slide the wires all the way through. And then when you crimp this, when you actually shove those little metal contacts that are down here up into those wires, it also cuts the end off. And man, that is such an easier way to make Ethernet cables. I've made Ethernet cables with all sorts of different connectors. Some of them had little carrier boards, so you actually have like a little piece of plastic that would be shaped like this, that has different holes in it. And I should hook my laptop up today. And you'd put your wires in those holes, which would then line them up perfectly in there. So a whole little piece of plastic, which would be pretty skinny in the long run. So the wires would go through that way. Those were actually really nice because it allowed you to get all the wires like lined up outside of the thing. Then you just slide them in and then crimp it, and that piece of plastic just stayed in there. It was fine. Some of them don't have that. They just have basically the little slots up here. So you have to then like carefully arrange the wires by hand. You get them in the right order. You have to cut them to the right length, and you have to slide them in. Hopefully you slide it in far enough. All sorts of fun games to be played. And we'll be talking more about that next class when we go through our different labs that I'm going to have you guys completing. So. All right, too far. So move towards the M12 connector. I don't actually know how you would make one of those cables. I've never done it. So, but still, a lot of nice benefits to this cable over the RJ45. Now here I have all of, not all, most of the different types of Ethernet, or of, yeah, Cat5, whatever you want to call it, cable. All right. So at the top left here, this would be our most basic one. All right. This would be our UTP, our unshielded twisted pair. Again, what's used in basically all, yeah, all office environments in your home, most of the places. All right. Moving to the right one, we would have F UTP. Really wish I took my laptop up now. All right, and that F is for, if you haven't guessed it, foil. All right, and in this case, it's unshielded twisted pair with foil wrapped around it. All right, our next one is S. I'm not going to keep writing UTP out. Shielded twisted pair. So again, this inside core, nothing really has changed here. All right, the only difference is we've added a braided shield around the outside. In this case, we have a foil. Do the shield and the foil, in theory, provide the same protection? Yes. All right. They are both a metal structure that is going to be wrapped around it, which in theory should help with grounding and interference, reduction of electrical interference from other outside objects. However, the braid is going to be a lot better. All right, it's a lot stronger, it's thicker. In theory, it is actually completely wrapped around it with everything touching, where the foil in your hand might, as it wraps around, might just loop underneath and you might not have a great connection right there. So just kind of something that you do need to, or might want to keep in the back of your mind. And then down here we have SF, which is our shielded and foil. All right, and again, this is still UTP, unshielded twisted pair. All right, and that's because again, the pairs themselves, nothing special about them. All right, they're just, we have shielding and foiling on the outside. All right, then we have U/FTP, and this is unshielded foil twisted pair. So in this case, each twisted pair has its own foil wrapping. All right, so it's a little different than up here. In theory, this foil up here is trying to protect all the cables at once. Down here, the foil is only trying to protect one pair at a time. So a little bit of a give and take going on there. Our next option is, let's see, this is F/FTP, yeah, F/FTP. So now we have both foil around all four pairs as well as foil around the individual pairs. All right, I am missing, because the website I got these pictures from didn't have it, was an SFTP, so shielded/foil twisted pair. All right, it actually used the exact same picture there, which kind of annoyed me. But just imagine, this braided wire instead of that foil there. So again, we keep just, every time we do this, we're probably increasing our interference capabilities a lot. And then like the mother of all cables would be anyone guess? I'll give you a second just to mentally take a guess. Yeah, that's right. The SFTP. All right, so we have foil twisted pairs with foil with shielding. Holy moly, that is a lot of electromagnetic interference reduction and mitigation, whatever you want to call it. So there is definitely a lot going on this slide, or on that wiring there. So kind of shows you all the different differences. And unluckily, until you're in an industrial environment, and everyone's going to be different, and every cable location is going to be different too. It doesn't matter if you are sitting, or it matters, I should say, if you run this cable over a 4 horsepower induction motor, or if you run it 20 feet away from that motor. All right, that will have a big difference. And the other thing that you might need to be careful of, or should be careful of, is running Ethernet by power lines, because those, especially in industrial environment, are going to be carrying a huge load for the most part, right? If you're running that not over the motor, but over the motor's wires, every time that motor turns on, there's a big surge of energy, lots of current flowing through that wire that's going to radiate electrical interference. So not just the equipment, but also the power lines is something that you do want to be aware of and try to keep in the back of your mind. So yeah, there is a lot going on with those cables themselves. But every industry is going to be different. Every company is going to have its own requirements. And some will say, oh, it doesn't matter. Some will say, oh, we only use this. Those types of things. if I were you guys and you're in charge of the ones that's picking, like, purchasing equipment or requesting equipment to be purchased, I would just go ahead and request that you get one type of cable. Like, just go the ballsiest that you can that your company will let you buy. I don't know a price difference between these types of cables. Let's see if I can quick find a price for one of these. Oh, no. Um, yeah, nothing really is popping up. Let me hit the shopping button and see if that gives it to me. So this one, this is just foil. It's not anything super crazy. All right. Anyway, I'm not gonna spend a lot of time looking. But I would just say just buy one type of cable and stick with it. All right. When it comes to your job, you don't want to have to worry that I grab the right Ethernet cable when you're making a new one or running equipment or whatever. Just buy like 1,000 foot of something. Keep that reel on hand, and as you get near the end, just tell your company, well, we're going to need another 1,000 feet at some point soon. So you just have it waiting and ready. So always try to have stuff for when crap breaks down and not be trying to scramble to make it up. So, all right. So that takes care of that. Now, latency. This is the big issue. All right, as we talked about. Excuse me. Latency is the time it takes for me to send something for the sender to receive it. And sometimes you'll hear this as a one-way latency. Sometimes you'll hear it as a round-trip latency. So that is something that you do want to just kind of keep in the back of your mind of which type of latency are we dealing with in this instance. So definitely an issue. And it really does depend partially on the networking type that you're using, whether you're using a TCP type of connection or a UDP connection, because TCP is definitely going to be a round trip. UDP is going to be a broadcast and we're done. So it's more of a one-way type of connection. I actually updated the last PowerPoint, which we'll bring up at some point, as I found two little animations which are great, showing you how TCP works versus UDP. So kind of a really nice little animation. So I'll bring this up in a little bit. But anyway, industrial processes often require scans in the 5 to 20 millisecond range. So extremely short, right? We don't want to be having to wait 20, 30, 40, 50 milliseconds for something to come back. You might even have some really demanding processes that are actually down to the 2 to 5 millisecond range, right? 5 to 20, that's too much. We're going to miss an input, or the motor's not going to change the speed at the right time, or stop. The piece is going to stop in the wrong place. So there is a lot going on in the industrial environment. For those who've taken my PLC class, you know this, that we're programming things and it's like, oh, I gotta stop this part at this location. I don't want to go past it. I gotta stop it at this location. And a lot of simple PLC programmings are running in the 1 millisecond loop range, so 1,000 times per second. Even slow ones that we've written in classes are only like 2 or 3, so 300 to 500 times per second. So we're running really fast. Now, as you get to larger programs and things like that, okay, it might take a little longer, but still, they're running 50 to 100 times per second. So definitely something that you need to be aware of, per se. So on a 100 base T Ethernet for a mono-reloaded 100 station network could range anywhere from 10 to 100 milliseconds. All right, which again for industrial applications, not probably going to be acceptable. If you're going to be at the 10 millisecond time, hey, that's fine. 100 millisecond, again, probably going to be too long. This again is acceptable for offices, for home use. 100 milliseconds, no issues. All right. If you're ever curious, all right, we can do a little quick experiment here. Go ahead and go that button. Yep, and we can do a little just a ping of Google, www.google.com. I know we did this the other day, but here you can see my response times right there: 11, 13, 12, 12 milliseconds. All right, so overall pretty short in the long run. Let me go ahead and quick just check something here. What Google server am I using? Oh, actually, let's just do that. What is my IP? All right, let's just do that. Now I'm going to try pinging my IP address in Vienna. Not gonna sure if it'll respond, but there we go. So yeah, we are going all the way across the world here. All right, to Hofburg, Vienna, and we're still only getting 120 millisecond ping time. So yeah, 11 for real close stuff on the internet, 121 for real short for long stuff. So we're still getting pretty high speeds there. I don't know. Let's try Finland. Let's see Ram. Let's see what that one gives us. Okay, let me refresh this. Get my new IP address. Ping 194.34.133.92. All right, that one's at 107 milliseconds. All right, so we can get some pretty simple speeds and things like that. Wrong button. That one. So something to think about in the long run is those ping times and things like that transfer. But it's really not ping. It's more of network transfer and things like that. And this can this could go down a rabbit hole because if you're some error process occurs or some network interface drops, you can get stuck in a loop, right? You could go, my data is just getting passed around from point A to B to C to A to B to C to A to B to C, and it's just looping and looping and looping and looping, which is not a good thing, right? Until the timeout, the time to life occurs, and it goes, okay, that packet's worthless, and then your computer says, hey, I still need that information, and sends it again, and now it actually gets the new path from point A to point Q. So, but that can cause lots of delay, which again is bad things. So, something to think about. Industrial utilization is on our networks. We're usually only going to utilize like 10% or less of that, of the total capability of our Ethernet equipment. We're normally more in the 3 to 4% range, and this is to help keep packet collisions down, so having to resend data, all those other types of things. So a lot of going, again, there's more to designing a network than, oh, I've got 50 ports, let me plug 50 computers in. No, it's, well, I got 50 ports, each one's only going to use so many bits, and so we're going to have a 5 gig network connection from point A to point B. Okay, we can have all those computers plugged in. If I only have a 1 gig, okay, I need to run more wires so I can have a better data bandwidth so we can have all those computers plugged in. So again, there is a lot going on there. Now, with the advent of gigabit Ethernet and switching and right now, the size and overhead of the Ethernet frame, which we talked about last class, if you remember, all those different packets, we were sending, what was it, 32 bytes times 5, no, 32 bits times 5 minimum. So we were sending 20 bytes of information minimum for an Ethernet frame. And I don't think that even included any of the information that you wanted to send. So there's a lot of overhead on that Ethernet frame, a lot of stuff that we have to send. All right. So this is definitely something we need to think about. So for example, if you only need to send 2 bytes of data, but there's a minimum message size of 60 bytes within Ethernet, you're transmitting 58 bytes of information that you don't actually need to send, but you still have to physically send that data. So now the other side has to receive all that data and those types of things. And with 100 meg and a 1 gigabit full duplex communication, this does decrease this as an issue. Now that we're getting to the gigabit point with switching hubs and VLANs and things like that, deterministic Ethernet, deterministic real time, basically sending things saying this is a priority, needs to get there as soon as freaking possible. This concern is overall not a big issue anymore, but it still is something that you do need to be ready to deal with at certain points, depending on the age of their network and the hubs and switches and things like that that they're using. If they're not up to the task, then maybe it's time to replace them. We've talked about subnetting. All right, so we talked about subnetting, network partitioning last class, and for your office, it's a nice thing for IT to have just to keep things organized and restrict access to things. However, when it comes to our industrial networks, this is actually so much more important. All right, and industrial networks aren't just manufacturing; they're power level. Right? If you go to power companies, they're using these industrial networking to keep all their equipment talking and being able to control things and increase this and say, oh, this is going power. We're going to send so much power this way versus that way, and we're having issues with this thing or whatever the case is. Imagine if someone hacked into that network that was controlling the power grid. Ooh, that's bad news bears right there. All right. So this is definitely something that we do need to keep in the back of our mind. Security is going to be a huge concern, and subnetting will definitely help with that, because if you have your network partitioned right, people from network A can't get to network B, and if network B is where all your industrial equipment is, that is a very good way for restricting network access. Another benefit to networking partition, for subnetting, is for speed and response time of the network, right? You have at your company, you have 2,000 employees or even 500 employees, and they all have, 500, a device or two on the network. That's 1,000 devices there. That's could be a major bottleneck if you had all of their devices or their laptops, their phones, their computers, and maybe their office phone, not their cell phone, but their cell phone as well. 500 people, that's 1,500 devices on the network, plus all of your industrial equipment. That's a lot of traffic to be dealing with. So by partitioning it off again, now we have stuff only worrying about the networking side, the industrial side of things, and you guys don't care about the other stuff, but only the industrial stuff. Um, some PLCs or some network industrial equipment will do what's called exception reporting. All right. So when my PLC is looking for information about whatever I/O or our remote, they're too far away to run normal cables. We run an Ethernet with another device there. They'll do exception reporting, which is they only report things that have changed. All right, and that helps keep our network traffic down. Right. If every time I have my remote I/O here. I'm gonna go with RIO, and that has 32 devices on it. Right, I need to send 4 bytes of information every time I need to communicate back to the PLC over here. Well, I'm only going to say, okay, here I have 32 inputs or whatever. I'm only going to send the things that have changed. All of a sudden, maybe now I'm only sending 1 byte of information every loop of code type of thing. So that decreases our network traffic. And again, you may think one device doing it, not a big deal. If you have 100 devices on your network all sending 4 bytes, that's a lot more information to be sent. So um, that is going to be a nice big key. Another thing with network partitioning is, again, this comes back to what we've talked about before, but switches versus hubs. All right, switches are going to be a necessity because they are going to help reduce latency. Remember, switches are smart hubs. They help focus the information the direction they need to go, not just kind of broadcasting out to everybody. And when everybody's getting messages, then they have to read those messages and go, that's important, or I have to ignore it. That is processing time. So there's switches are basically a necessity at this point. And again, I don't really know anyone that sells hubs anymore. That's just a little hub, but it is something that we do need to kind of keep in the back of our mind. So now the application layer. All right, for those that you remember that this is the OSI layer. This is the top layer. This is layer number 7. All right. And the way that one of the ways that industrial applications are starting to use the OSI layer, use Ethernet and make it work for their needs, is they're using special application layers. So they are modifying things. And yes, I had said layers there, plural. And one of the key thing here is that annoys the living daylights out of all of us in the industry, and you will be annoyed at this too, is every vendor has their own different type of application layer, their own special one. All right. So, which means that our Siemens hardware can't interact with our Allen Bradley hardware, which means it can't interact with the Click hardware. It's like, you gotta be kidding me, people. We need to get a specific open protocol so that way everybody can communicate with everybody else's hardware. And you might think this isn't a big issue. We just buy stuff that has, when we're installing equipment, we just install stuff that all works together. And yes, that is a great idea. However, sometimes when you're buying equipment, it comes pre-installed with a PLC already in it, and you didn't have control over that. They're like, hey, yeah, we got this equipment for you. And, but it's like, I need something different. I need Allen Bradley. And they're like, oh, well, that's going to cost you an extra 10 grand. Like, my equipment already cost 150. Why do I spend 10 grand to get Allen Bradley on there instead of the Siemens? All right. So it would be really nice if all the manufacturers would just accept that we need to work together to some extent. However, that's going to affect their pocketbooks, right? Because once you buy into the Siemens ecosystem, you're stuck there unless you're willing to have multiple different ecosystems. All right. And you may go multiple different ecosystems, and that's not the end of the world, right? But having a tech try to troubleshoot multiple different ecosystems means he has to know multiple different pieces of software. It means he has to be trained on multiple pieces of software. And for those, again, who have taken my intro PLC class and are going to be taking my advanced one, you will be diving into this. We've already used TIA Portal from Siemens. Now this semester or later, we're going to be using RS Logix 5000 from Allen Bradley. So there is definitely a bit of a give and take going on here for dealing with this, which is rather annoying in the long run. Now we do have MMS, all right, which does not stand for multimedia messaging in this instance. All right, that's when it comes to your cell phones. but this is the Manufacturing Messaging Service. All right, and this has been a protocol that has been developed to that has been promoted as truly open for the automation application layer, but it has limited acceptance, right? This is not all the manufacturers getting on board saying, all right, we're going to start using this. No, it's, well, we should use it, but I don't know if I really want to use it, all those other fun things going on. So kind of annoying in that aspect. But, and again, maybe at some point we'll get to that point where everything works with everything else. Kind of like old serial communication. Okay, we use a different plug. Well, I have to use adapt a plug, but I can still communicate with you. Now we're getting those much higher capabilities and things like that, and it's just, to me, causes all sorts of stupid problems that don't have to exist. They almost exist because, again, companies want to make money, which I do understand that, but at the same point, it's so much havoc for the rest of us. All right, so I really wish that we would all be a bit more, friends at this point, but that doesn't seem like it's going to be the case. So anyway, so, industrial Ethernet protocols, and this kind of walks us through some of this. So we have the standard software standard Ethernet. So this uses the standard Ethernet with the TCP IP protocol, with some mechanisms built into the top application layer to enable real-time communication. All right, and this is kind of what Ethernet IP is based on. All right, I've got a little bit more about Ethernet IP in the next slide, so we'll come back to that one. So overall, this is probably as close to standard Ethernet as you are going to get. All right. The next one, Open Software Standard Ethernet, uses the standard Ethernet layers with new protocols that manage access to the network. So we are modifying things at this point. So it may or may not work with standard Ethernet hardware. All right. Now, I'm going to assume this whole standard Ethernet part right here at the end means that we are going to be working with normal hub switches, routers, those types of things, which is a good thing. But we're modifying more of, say, that OSI layer. So we're maybe not following all 7, we're only going to follow 4 of them or something along those lines. And after that, we're going to be changing it up. Now, one of the big benefits of this is we have the ability to synchronize the data being sent from each node to ensure priority data is sent first. So we can actually go, hey, that PLC's data is more important than PLC A is more important than PLC B. So we're going to send PLC A's information through first. All right. So a little give and take there. And then the last protocol with industrial Ethernet is Open Software Modified Ethernet. So this says it's still based on standard Ethernet hardware. However, we have new protocols and additional complementary hardware. That's the key to this whole modified part, to ensure determination or determinism, which is that whole delivery and things like that. And this is where EtherCAT, Sercos 3, Profinet all use this architecture. But they do so with different hardware and transport mechanisms. So again, can't use them interoperable. So it's like, you gotta be kidding me. For those just are curious, Profinet would be the Siemens-based one. I forget what EtherCAT and Sercos 3 are based off of, but there are just some different options out there. So now, for the OSI model for that industrial, that Ethernet IP, all right. So they've taken the OSI model and kind of broken it up for you, which is really nice. So the OSI model, when we're talking about layer 1 and 2, that's dealing with purely with anything Ethernet based. All right, so this is the physical hardware and the MAC addresses. All right, when we go to layers 3 and 4, we talk about TCP IP again, which we talked about last semester. And again, here's that UDP or TPC option. And then we get into this CIP, all right, which is 5, 6, and 7. Now, I believe on my next slide I have CIP is Common Industrial Protocol. All right. So those types of things are going to be going on. I do have some examples here of, again, some different types of industrial Ethernet. So Ethernet IP, which we already hit up. IP right here stands for Industrial Protocol. This is going to perform at 5, 6, and 7 of the OSI, as we have listed here. That's the CHIP layer, which I said is the Common Industrial Protocol. This is Ethernet packets used with the Industrial Protocol of CIP, TCP, IP, and or UDP layers to provide the required data to your controller. And this does promote consistent implementation of automation functions across diverse ecosystems of products. So again, this is another one of those ones that they're trying to make a universal thing for, and not everybody is following suit. So that's kind of annoying in the long run there. Now, I did say that I wanted to bring up last class's PowerPoint because I wanted to show you two specific slides on it that I just recently added. So let's go ahead and hit this button there. So here we have the TCP/IP option. All right, so you can see how, you know, this is, I don't know if this is requesting data and then, send, coming back, but basically data goes to it and then comes back. All right, so it's doing a full loop for TCP/IP. And that's for error checking to make sure the device actually has it, all those other fun things. UDP, on the other hand, as you can see here, is just a send. It's just this flow meter, pressure sensor, whatever you want to call this thing right here. It's probably a flow meter. But anyway, it's just that transmitting data. It's just being like, hey, here's the information you're going to need soon. Hey, here it is again. Here it is again. Here it is again. And it's constantly just sending it out, sending it out, sending it out. Where in this other option, it's having to request the data, basically. So it's, you know, this one's saying, hey, I need some information, and it's the VFD. It's going, oh, here's that information for you, and sending it back. I really wish they'd changed the numbers there as it's getting transmitted. But it's really kind of a nice. You can just very blatantly see the difference here, which to me is really nice, simple, way of solution for this. So, all right, and that is all that I have for this network for industrial Ethernet at this point.